listening to the Data Flowcast, where we unlock the secrets of mastering Airflow for data engineering and AI.
All right. Hi, everyone. Welcome to the Data Flowcast. I'm your host, Kenton Danis, and today I'm joined by Han Zhang, who is a senior software engineer at Conviva. Han, how are you doing today?
I'm great. Yeah. Thank you for asking.
Great. Yeah. Well, it's wonderful to have you on. For our listeners, for today's podcast, we're going to discuss how Conviva uses Airflow as the back end of their data platform. But before we get into all of that, I want to start with a little bit of background. Can you tell me what Conviva does?
Sure. Yeah. Conviva is a intelligence platform for digital businesses. We use client-side telemetry data to transform every consumer interactions across apps, websites, AI agents into an outcome-based intelligence. We can surface real-time actionable insights and help our customer to feel growth and customer satisfaction. The relatively scale that we're operating at is we process 5 trillion events every day, and it takes less than 30 seconds from the moment we collect the events all the way until those insights surface up on our dashboard.
Wow, that's fast.
We had a lot of pressure to do this in real time.
Okay, great. So you have a streaming analytics platform then for your customer data. Very interesting. And what does your team do?
Yeah. So for our team, we're a control plane team. So our main goal is to orchestrate multiple different Conviva internal components to work with the batch workload. As I mentioned before, historically Conviva is heavily focused on the real-time streaming analytics. So a lot of components are built optimized for streaming environments. And in the beginning, like about 1.5 years ago, we were tasked with a mission to turn the whole pipeline into a batch-oriented workload.
Yeah, so just to make sure that I'm understanding correctly, so you have these batch pipelines that are helping to support the data platform that powers your streaming analytics business. Is that right? So you still have a streaming platform, but there's batch processing underneath it, or how does that work together?
Yeah, so we are more complementary than the streaming to the streaming components. So like a lot of functionalities on our main product is powered by the streaming pipeline, but for certain functionalities or certain pages, they need batch processing capabilities. Like they can't do that in real time, or they can't do it. Sometimes the data is already, or we need to enrich the data in an offline process. So once we finish that part, we need to rerun the compute engine and ingest into our database again. So we are complementary part of on the product service side. Some functionalities are powered by us. Yeah.
Okay, got it. That makes sense. And then how does Airflow fit into that?
Yeah. So in Airflow is like the heart of our orchestration implementation. We picked Airflow because of the orchestration framework and the capability they offer. The Let me dive into the architecture of our control plane a little bit. So hopefully this helps illustrate where Airflow fit in. So there are 3 major components in our control plane. The first one is a web service endpoint and has a dedicated persistent database storage. This manages the uh, high-level business logic. Um, for example, it manages the instance life cycle, and if something failed, how do we roll back and how do we clean up the intermediate corrupted results? And we also want to enforce a read limit. Like every customer, they have a certain quota, and we don't want them to have too many running instances at the same time. This is we call it the web service orchestrator components. And the heavy lifting is the actual orchestration happens with Airflow. So the web service invoked the Airflow to create a new a new instance of the target workflow, and Airflow orchestrates multiple tasks and the coordinated dependencies. And once the upstream finishes, evoke the downstream and then do some sanity check. And once the workflow finishes, either succeeded or failed, it notify back to the web service. So we manage the overall life cycle of the given task or workflow. And the third component is the data plane. We have a pool of resources in multiple Kubernetes clusters. So Airflow only does the orchestration. If it needs to invoke data plane processing, it will create pod or Kubernetes pod operator to actually perform the heavy lifting of data processing and compute the metrics and persist the metrics, notify the show up in the dashboard.
Okay, interesting. So you've built this entire platform around Airflow, or Airflow is powering your data platform. I'm curious, what made you decide to build this platform in the first place? You touched on it a little bit, I think, in your introduction, but maybe just to reiterate kind of why you needed this complex system as opposed to just using a batch orchestrator.
Yeah, I guess there's a couple. This is a very complicated question. There are a few parts. So, I mean, let me explain why. Let me break it into two parts. The first one, why we decided to build a batch-oriented workload, and then why we choose this Airflow versus others. Historically speaking, Conviva is heavily focused on the real-time streaming data analytics. So it's everything we process one time, and then the dashboard just keep loading the pre-computed results. About 1.5 years ago, the company had give us a mission, like, okay, here's what we have. All the internal components that we build, our proprietary compute engine, and the way we process data and we clean up data and database ingestion, they are all designed for streaming use cases. However, there are more and more new applications and new use cases that cannot be satisfied with one pass streaming processing. We need to build up this batch processing capabilities. However, given we already have all these components, can we change the way we use them? And that's why we need this orchestration capabilities to build up this batch workload, batch processing pipeline. And with that, we realize we need to pick an option for the orchestration framework, or we could build it ourselves. And there's a long story. We go through we spend a lot of effort evaluating different options, and we ended up with the Airflow. If you like, I can jump into the history, the evaluation process we go through, and why we decide to end up with Airflow.
Yeah, I would love to hear more details about how you ended up with Airflow, especially considering it sounds like one of the options was build your own, which is quite challenging, I think. So, yeah, tell me more about that.
Yeah. So we first did a wide variety of candidates options, and eventually we landed up with several options. The first one is Airflow. Yeah, just using Airflow as is, and this delegate all the orchestration and heavy lifting to Airflow. The second one is Celery. Celery is a framework that Airflow is built on top of Celery. Yeah, so it's much more lightweight options compared to Airflow, because you directly just pick whatever you need and build meeting functionality that is needed. And the overall code base would be smaller, and the performance will be just, if you only care about performance, that's much better than Airflow. And the third option is another framework. It's a Temporo. It's a Rust-based orchestration framework. And we had several evaluation criteria. So we are mainly, I'm trying to recall what was the criteria. So we basically built up this evaluation matrix with several evaluation criteria. For example, the first one is performance and overhead. And the second one is how comprehensive it is this framework has for support for observability. And the third one is the maturity of the ecosystem, like third-party integrations. And specifically, we care about Kubernetes support and how mature it is. And the fourth one is our internal expertise, which is do we have any Conviva internal operational experience with framework X, Y, Z? We don't want to step into a minefield and then realize everything blow up. I guess one more criteria is we are a quite small team, and we are tasked with a big ask. So the time to market or how much development effort and how we can focus to deliver this end goal is also a plus factor. The specific consideration, you are asking why we didn't go down the path of building everything by ourselves. As a matter of fact, we in other projects or other teams, we have used Celery before, and those are for very latency sensitive workload. Like we did a comprehensive comparison, head-to-head comparison between Airflow orchestration overhead versus the other team's implementation, very lightweight orchestration based Celery, and of course the difference is quite noticeable from seconds of orchestration overhead to milliseconds of orchestration overhead. However, you give up a lot in this process. Like we like a lot about Airflow because of the ecosystem and specifically about the observability side of things. Like once you get it up and running, you can go there and check the history of the workload and check the workload logs. If something goes wrong, you can see which step it went wrong and go to the corresponding logs or go to the Kubernetes cluster to figure out. Those are the things that we need to, if we went down to the Celery route, we will have to implement everything ourselves. And we don't, given our resource constraint, we should spend most of our time building the integrations with our internal component, like how to make the streaming design for streaming compute engine, real-time compute engine, how to make it work in batch mode, and our ETL ingestion to database. How can we modify it so that we can run it with a batch of outputs? Yeah, and this is the additional overhead, like the overhead going from seconds to tens, hundreds of milliseconds. This definitely a good plus for the lightweight implementation, but it's not a deal breaker for us because if it's a batch workload, typically sometimes it can take hours to finish if it's a large customer's data, right? Yeah, unless you're under a really tight constraint about a return to answer in 5 seconds, then we need to optimize that. But we've done that in the streaming pipeline. There's a different requirement for our batch workload. I forgot to mention the other comparison. We talk about the Airflow versus the Celery, and the other comparison is another framework for temporal. And this is they're also pretty fast, and they have a variety of support. However, what draws us to the Airflow side is with the ecosystem of Airflow is much more mature and way bigger than the new up and coming framework, up and coming contenders. Yeah, it turns out to be very helpful. Like if you want to work with GCS integration, if you want to work with HDFS integration, they're all like it's all pretty standard, and there's answer out there to help you get quickly started. Especially in this day and age with the coding agents, the more training data you have, the much better it will greatly accelerate our speed to deliver new features or new workflows.
Yeah, that makes sense. Batch orchestration definitely becoming more and more important with these more advanced use cases that it's supporting. And I love hearing that the ecosystem and community around Airflow was one of the reasons you chose it, as with being able to support it from, people having the background of already using this tool. I can definitely imagine that it's a lot easier to use Airflow than to set up your own with Celery. Even just setting Celery up for some open source Airflow users can be challenging. So building a platform around it, I think, would be quite difficult. And as you mentioned, maybe not performance increases that are needed for batch pipeline. So that's really interesting. In terms of how your platform is set up now, curious, are the internal users, like the folks on your team, interacting with Airflow directly, or is it used purely as a backend in the architecture that you've set up?
Yeah, I guess I would say it's a mixture of both. As I mentioned, we have a standalone orchestration services, web service that's provide the API endpoint to invoke the workflow execution. And the Airflow is from the architecture architectural point of view, it's behind the scene. So the web service directly create new workflow inside Airflow. However, because the built-in functionalities, the dashboard, the monitoring, the log exploration of Airflow, we also open up the Airflow web page to our users, to our internal users. So if they trigger a workload execution, and they can just log into this Airflow dashboard and see how it's going. And if it fails, which step failed, and just notify us, let us know about the and just notify us, and we can go fix it. Yeah. So they have direct visibility into the Airflow execution.
Got it. So they interact with the UI, but they're not writing their own DAGs. That's all managed by how the platform is set up.
Right, exactly. Yeah, we implement if there's a new ask for a new type of workflow, they communicate with us when we read out the design of the high level task dependencies, and then we go implement those. If something is needed, we implement an adapter to make a new functionality or new components compatible with Airflow task.
Got it. Yeah, this is a pattern that I've heard about quite a lot, actually. And I'm curious if it has helped you be more efficient and be able to move faster, since a lot of the end users don't have to write their own pipelines and you've set it up in a way that is more kind of automated.
Right. Yeah, definitely. Because we manage the implementation, the different adapters implementation for our internal components. So we know what's there and what's missing. And if it's a new workload request coming in, we can reuse all the existing components because we know the inside out of what's in our code base. Uh, you can imagine if someone from other team, they come up, they want to design a new end-to-end workload, and they might tend to implement everything themselves, which is counterproductive because we already have the building blocks. We have an adapter to pull our central configuration services. Like all of our config are stored there. We already have capability to do that, and we already have a way to invoke batch mode execution of our compute engine, and we know the quirks and features of all this existing components, and we can make it much faster and get something up and running like in less a day. Yeah.
Got it. Yeah, that makes sense. And now that you've been working with this platform for a while, are there any optimizations that you're looking to make in the future?
Yes. Right. There are quite a few optimizations I wish we have implemented in our own uh, installation or in our own Airflow instances. Uh, Chances are there's something already out there. We just haven't integrated yet because of the ecosystem, huge variety of ecosystem. But there's just some missing gaps in our current implementation. For example, the first thing is the user management and integration with our LDAP services. As I mentioned, we open up our web dashboard to Conviva engineers and Conviva users. They can monitor the workload. However, uh, inside the company, we use LDAP, and everybody has an account there already. It's just extra hurdle we need to figure out how to give them access. We have to create a Airflow account for some of them, and there's a different set of credentials. It will be better if more seamless if they could just directly log in with their own LDAP credentials. And the second optimization I wish to see is more easy to use integration with the secret management services. For example, we use Vault. Internally, we store all our sensitive credentials there. However, for our Airflow, we leverage their variables and connections, specific connections to store the credentials. It's just extra hoop we need to jump through. Like when we have here's a service account for this GCS project, and then we have to copy that from the Vault to our Airflow cluster configuration. And it makes synchronization that a bit difficult, but it's manageable.
Yeah, for sure. So you haven't set up the secrets backend yet.
No, not yet. Yeah. And the third one, the final one, is probably how inside or more easy to use scheduling algorithm for the scheduler when you have multiple task instances. We have multiple workloads share the same Airflow instance, and they create their own task instances, and a lot of them are queuing or pending. Rather than rely on the first in, first out, first come, first serve those scheduling algorithm, we might want to have different weight or different, more customized scheduling. Like for this workload, we want to make sure we got the process as soon as possible. And for this batch work, for the other workload, they can wait and just make some progress every few hours. As yeah, it's a more tailored scheduling algorithm and an interface to implement that will be very helpful.
Yeah, definitely. So using like a priority weight or something on your tasks, I think is what it's called in Airflow.
Possibly, we looked into that. Even that is not maybe 100% fit for what we want to achieve. It's a very tailored to our yeah. It may be hard to calculate the priority weight for different task instance. It's like for this workload, what's the SLA and how far progress are we on? Like, and therefore, the other workload specific scheduling in the same resource pool.
Yeah, yeah. Okay, got it. That makes sense. Well, maybe a related question. I always like to end my episodes with a standard final question to folks, and that is, what would you most like to see from the Airflow project in the near future? So maybe it would help with some of your optimizations, or maybe not.
Uh, yeah, the biggest thing I wish we can have is the version control or history tracking of the values we set for variables and connections. And yeah, because for example, in variables, we store different configurations, and the pod resources is also part of the variable values. And if we make some tweaks or adjustments, the history is lost, at least from the UI. I'm not sure about inside under the hood whether they still store that in database. Yeah, and also for credentials, it will be better to have a visibility into what has changed and what in the past and who has changed that from one value to what. Yeah.
Yeah, yeah, that's really interesting. I would imagine some of that information exists in the audit log, although I'm not positive. But it sounds like what you're looking for is more like the DAG versioning feature that came in Airflow 3, but for connections and variables as well.
Yeah, yeah. Some may also refer to the Git history, like on GitHub, you just click on the history, you can see what point who made the commit that change it.
Yeah, 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 I can totally see where that would be helpful. Okay, cool. Well, Hun, thank you for going through all of that. This has been really interesting hearing more about your use case. Just to close us out, what is the best way for folks to get in touch with you?
Yeah, feel free to connect with me on LinkedIn, send me a message. Uh, I will get notification. I'm not very active, but I will get notification.
Okay, great. Well, we will include that in the show notes. Well, thank you again for coming on. It's been really great talking to you.
Yeah, thank you for having me.